We have to try to represent these two equations on the Argand diagram as loci. So if I were to look at this equation over here with z as the variable complex number, that means what we are looking at it is the modulus of z minus 3 plus I is equal to 1. So its locus is going to be represented by a circle with the center at 3, 1, and the radius is 1. So this is 1, that is why this circle must just touch the horizontal axis. As for this, I'm going to view this as if it is the argument of z minus 0 is equal to alpha. So if z is a variable complex number, that means what we are going to be expecting here is a half line with the endpoint at the origin and the angle that it makes with the horizontal axis, with the horizontal real axis is alpha. And for this angle alpha, it is given to me that tangent alpha is equal to 0.4. We can actually work this out using our calculator. Alpha will be tangent inverse of 0.4, and from my calculator, tangent inverse of 0.4 is around 21.8 degrees. What I'm going to further check is whether this line is going to be above this point, cutting through this point, or below this point. And to do that, I'm going to make use of this triangle over here. So if I were to simulate it over here, that means I'm looking at the triangle that starts from the origin. This point is 3, 1, which means that the vertical height here is 1 and the horizontal height here is 3. I'm going to try to find this angle and compare it to 21.8 degrees. To find this angle, it is going to be tangent inverse of 1 over 3, and from my calculator, this is about 18.4 degrees, which means that this angle is supposed to be smaller than this angle. So now we know that this half line is supposed to be above, is going to be passing a point that is above 3, 1. And at the same time, according to the question, that this circle and this half line is supposed to be intersect at 2 points, and these 2 points will be a representation of the complex number z1 and z2. According to the question, the modulus of z1, which means that the distance of the point away from the origin, is smaller than the modulus of z2. So since this distance is smaller than this distance, and if p represents z1, that means this point here must be p, since its distance is smaller than the other point, which I'm going to represent using point q. So this point will represent z2.